go ahead and get started. It's 12:01. I think some people will still be jumping on. But I want to welcome you again to MasterGraphics and HP's Additive Manufacturing and Education, kind of learning how cutting edge 3D print technology we see affecting the education market. So Jeff's going to run the slides. Jeff, if you want to go to the next page, I'll just go through the agenda and introduce you. You can hit down and I think there's some animation. But first of all, my name's Kevin Carr. I'm the president of MasterGraphics. We've been in the 3D print world for about 12 years and are very happy to be partnered with HP the last 3 years with the revolutionary technology. So today we have Jeff Fawcett. He's the HP product marketing manager. And then also joining us, listening in, is Tim Ratterman, who's the HP educational specialist. They find that the education market is so important that they have a dedicated rep, and Tim's an amazing person. So everyone's going to be unmuted. If you have any questions, feel free to dial it into the chat box, and I'll kind of mediate it. But on a real high level, I'm going to hand it over to Jeff. He'll talk about kind of the Industry 4.0 revolution, a little bit about HP technology. We'll talk about 3D print education. And then we have some action items or follow-up items at the end, and then open it up to Q&A. So with that, I'll turn it over to you, Jeff.
Great, thanks so much, Kevin, and it is a pleasure for me to be here today. As Kevin pointed out, I have two roles, two hats I wear right now. Actually, I'm the product manager for the 500 series of printers, and you'll hear me talk a bit about those a little bit later. And I'm relatively new to leading the education segment, and hopefully through this presentation you'll understand why HP is so strongly feels that education is a key player in helping to change the world as we know it today, to accommodate the future that holds for 3D printing. So let me jump in. This might seem a little academic to start, and I believe me, we'll get into some real meaty stuff here in a moment. But really, it's worth kind of thinking about how history and how technology has played such a massive role in shaping the way we live and work. And when you think about the pre-industrial age, it was a little more than 150 years ago, when the craftsman was the producer, the maker, and the manufacturer, right? Thanks to the Industrial Revolution, which, as many people point out, is the biggest turning point in human history. The handmade works gave way to the blueprints and the specs, and linked this to mass production. And this is where we started to see this split between the designer and the manufacturer, all for good reasons, but that did tend to create some additional problems. As we fast forward, to the 100 years of the internet era, the basic process remains the same, only computers are added to speed things up. Innovations like CAD or CNC machines all have played their part in making this transformation. And this also was the beginning of inventory and warehouses and very complex supply chains, which we definitely felt the strain of that during this global pandemic. And when you get to today, we're entering the era of the 3D transformation. So I know there's been a lot of hype around 3D, particularly as it translates to affecting the manufacturing sector, but that hype is actually quite real. And I have some examples I'll showcase in a moment. And I like to say that the future is now with how 3D is truly transforming manufacturing. But we see even bigger goals in the future, or bigger transformations in the future of this next industrial revolution. In some places, this is called Industry 4.0. This has the features of, say, a smart factory, which provides highly flexible production systems for individualized goods. And at HP, we go beyond the smart factory. Our understanding of the digital transformation is broader, in that we're focused on redefining the boundaries between the physical and digital worlds, creating this new blended reality. So when you think over the last 150 to 200 years of the industry as we know it has dramatically changed. In fact, we're seeing some of this transition already happening today, that's starting to look more and more like this Industry 4.0 or the next industrial evolution. So let's take a look at how we will unlock this future and the role that higher education will play in that future. So the truth is, as I said, there's been some hype around 3D technology, and as you probably know, it's been around for 30 years or more. But we feel like with our technology, we've reached an inflection point that has truly unlocked its potential. So we look at this in kind of two ways of really disrupting the manufacturing sector. First is the unlock, and then the accelerate. So when I say what we've done to unlock the 3D technology, there are a lot of barriers to really getting it into manufacturing, and we feel like we've solved them, right? So one of them is the product capabilities, and for this, I'm talking a lot about both the speed and the mechanical properties of the parts themselves. So the HP multi-jet fusion technology is truly innovative in terms of its productivity, not just in terms of, let's say, the layer time, so it's kind of layer to layer build time, but also some innovations around the architecture of our system, whereby it's more of a modular system that can print one job while the previous job is cooling, in fact, so to get really high utility of the device. The other product capability that the technology has unlocked is the mechanical properties. I think if anybody knows their experience with 3D printing, it might date all the way back to the old SLA or even some FDM device parts that were actually quite fragile or didn't really have dimensional accuracy. So with the multi-jet fusion technology using thermoplastics and strong layer-to-layer adhesion that you'll see in a moment in a video animation, again, we feel like we've truly unlocked the potential by producing truly functional parts. So that's one piece, the product capabilities. The other is the material price. So one of the other limitations of getting 3D into true manufacturing is the cost of operation. When you're trying to compete in a cost is everything world, and injection molding can spit out parts at a really low price, you have to address that in order to overcome those barriers. And again, our technology kind of came to the rescue here, is that we're able to not only have very high very high recycle rates with our powder, but we're able to drive down our costs with our architecture to really low levels. A lot of times you might see some like trade-off curves where you look at the difference between tooling up for injection molding versus 3D printing. We've created some crossover curves that get into the tens or even hundreds of thousands of parts before it could make sense to choose to injection mold instead. So again, this is really making people rethink the economics of injection molding. And then lastly, material selection. So you know, there are thousands of different plastics out in the world, all for very good reasons, very specialized, have particular properties for a specific application. So you need to have a broad material breadth in order to truly overcome the existing paradigm. And we're doing that with multi-jet fusion. In fact, just last week, we made a worldwide announcement of the latest material, polypropylene, in our multi-jet fusion lineup, a very commonly used material and one that we think will make a big impact. So again, those are all the things that our technology has unlocked. And we see that higher education can help play a role in helping to accelerate in ways of teaching the future innovators and future decision makers about design for additive manufacturing, how to change the way they're designing in a way that fully takes advantage of all that additive manufacturing can deliver. Also, the business leaders thinking about new supply chains. Instead of centralized offshore manufacturing, we can start to see models where decentralized onshore manufacturing starts to make sense. And then lastly, any help that the education market can provide in terms of smoothing standards and regulatory policies. So it's a lot that we're counting on here, but again, going back to the technology, let me say a little bit more about what we've actually launched and how we think we have unlocked this potential. So it starts back in 2016 at Rapid. We actually made the announcement at Rapid in 2016 in Orlando, Florida, of the new 4210 and 4200 series of printers. As you can see, this is what I was mentioning before, this modular technology. On the left here, we have the printer. On the right is the processing station. And in between is this build unit that goes back and forth between the two. This build unit holds the build chamber. So you can imagine that this processing station does all the mixing of the powder. You cart the build unit over to the printer, and that's where all the printing takes place. Once the printing is complete, you can remove that build chamber and then have a second build unit that can then swap in and start another print job while the previous job is cooling. This is what I was talking about with the continuous printing. The other, as I pointed out, is the economics to disrupt manufacturing. One of the keys, as I said here, is that our refresh rate. So this powder bed fusion is a highly recyclable process. So when you think about all the powder that goes into the build, you can reuse that for the next build at certain fresh to recycled mix ratios. Prior to multi-jet fusion, you had fresh ratios of maybe 50, maybe as much as 40%. With multi-jet fusion, we can go 80% or even higher with actually a full 100% recyclability with the latest polypropylene material. So this will help us to drive down our costs and disrupt from an economic standpoint. So that was in 2016. 2018 is when we introduced the 300-500 series. This is the one we'll spend more time talking about today. Happens to be the product that I was the manager for. This was a smaller footprint device as an integrated architecture. We developed this more to democratize this technology, get this multi-jet fusion technology into more and more hands so they can learn about how to use it for, let's say, prototyping or in-house purposes, maybe even some bridge production before making the leap and transition to the heavier production systems like the 4200, and later the 5200 was what we actually launched last year. The other big breakthrough with this technology is full color printing. This is the first technology in the market that offers functional color parts. There were other technologies in the market that made color parts, but they were nowhere near offering the functionality that the 580 system can offer. Moving on into the future, you will see the introduction of metal printing, as well as other high production systems. This slide doesn't reflect the fact that we actually did introduce a kind of a follow-on to the 4200 system with the 5200. That was announced last year. So we're continuing to innovate and pushing more and more into the mass production space. So to give it a little bit more of a flavor of how this technology works and why we do think it's so disruptive, I'm going to play a video, and along the way I'm going to pause at a couple of spots just to re-emphasize a few points about how this technology works.
Meet HP's most compact 3D printing devices, designed for convenient in-house automated prototyping and production. With the HP Jet Fusion 500-300 series 3D printers, accelerate your creation workflow by producing functional parts in full color or white, with voxel control in a fraction of the time. To begin the process, prepare your build for printing with HP's easy-to-use software. It lets you error check your 3D models and automatically pack them in the build chamber before sending the job to print. Prior to printing, the printer will notify you if it needs additional material or agents to complete the build. Load material by inserting the cartridge into its designated location. Once inserted, the material is automatically dispensed, mixed, and delivered to the print area. Pre-print and in-printer checks give you predictable quality output. Thanks to HP's unique multi-agent and multi-pass printing process, material is spread evenly across the build platform. A print carriage can...
I'm going to pause it there really quick. What you might have missed in that really quick movement of the carriage is that we have on the system two different carriages. One is spreading the material. This is this thermoplastic powder. That same carriage also has a fusing lamp. The other is our print heads, and these print heads span the depth of the print zone itself. So one back and forth motion images the entire bed, and then we pass over that printed image with 3 passes of the fusing lamp. And the foundation of multi-jet fusion is that we use thermodynamics, the physics of the black versus the white, to help fuse the plastic. So as you can understand, a white area that's the powder that's unprinted will tend to reflect the energy of the infrared lamp. The black areas where you did print will absorb the energy of the infrared lamp, and raising that and only that area above the melting point and fusing that layer. So what I was just trying to showcase here is the technology that we're bringing is actually leveraged from our 2D printing business, where we have these very wide print heads that can span the entire depth of the build zone, and that enables the fast printing. I'll continue here and you'll see some more of that.
Containing an HP thermal inkjet array passes over the work area, printing, fusing, detailing, and coloring agents on the material. During another pass of the carriage, the area is exposed to fusing energy, which bonds the part layers together. Unlike other 3D printing technologies, multi-jet fusion technology prints each layer of new material and agents on top of a previous layer that is still molten, so that both layers fuse completely and polymers can lock in with each other across the layer boundary.
That's a super important point, by the way, and that's a key differentiator of our technology versus others. Everything, when you think about strength for 3D printed parts, is the Z direction limitation. So when you think about, let's say, fused deposition modeling, where you're jetting this material onto a cold surface, you don't really get any layer-to-layer welding. You're really just relying on the stickiness of the material to stick to the previous layer. What you just saw is that because of our speed, we're able to fuse one layer and then come back and fuse the next layer while the previous layer is still molten, so that the energy we apply truly does weld layer to layer. And that gives us tremendous Z strength capabilities.
The build platform is then lowered layer by precise mechanisms, achieving fine detail and high-dimensional accuracy for small features, with optimal mechanical properties and delivering strong, quality, detailed, and functional parts. At any point during the printing process, you can monitor job status in the HP SmartStream 3D Command Center. When printing is complete, ambient air cooling ensures part integrity. Automated vibration and airflow then extract unused material from within the build chamber, and unused material is reclaimed inside the printer for future builds. During this process, material is completely contained within the unit for a cleaner, more efficient operation. After cooling and material reclamation, your parts are ready for retrieval and post-processing in a bead and air blast cabinet. Any final finishes can be applied. Get the parts you want when you need them, easily, reliably, and predictably, with immediate access to support and comprehensive, affordable training. Stay ahead and produce brilliant full-color and white functional parts with HP Jet Fusion 500-300 Series 3D printers. Color outside the lines of convention and bring your ideas to life.
So just to bring that point home a little bit further, when you compare multi-jet fusion to other technologies on metrics like the productivity rate, just general raw speed, the strength of the materials, I referenced again the Z strength capabilities of multi-jet fusion, the surface quality and the control that you can have for different faces of a part, overall dimensional accuracy, the lack of support structure. So this is a self-supporting technology. There's no need for support structure with multi-jet fusion, and the potential for full color. There really is no compare when you look across the different technologies in the market today. So what does this all mean when it comes to the commercial market and ultimately to educators? So the commercial advantages are quite clear with multi-jet fusion. One is around time, and it's not just the speed of the system, but it's also time to market. I can tell you there's a great example of this. When we were developing the 500 series, we discovered pretty late in the program that we needed to add an entirely new subsystem to the architecture. And you know, given our launch schedule and the time it would take to tool up and all this for injection molding, we saw that it was not going to be, we weren't going to be able to make it. So it was obvious to us that, oh, we just need to turn to 3D. So we did all of the prototyping and all of the testing, and ultimately a key portion of the production parts for this subsystem, and still made our launch window. So there's a lot of elements around the speed and the time to market that you'll see advantages of in the commercial space. I said before about the economic advantage of having lower cost of operation. This means you don't have to invest in upfront and expensive tooling, but also has other advantages in terms of inventory management. The performance increase, you know, again, you're getting the fast speeds, and I think in a case, let's say like even for a university where you have a model shop, you know, the ability to have a printer that can run fast enough during the end of quarter or senior project time is going to be really key. The personalization capability. So this is I think one of the real key advantages of 3D printing in the future, is being able to personalize products or customize them in a way that you can think of. Instead of low mix, high volume, you can think of high mix, low volume applications. And then lastly, the sustainability of both in terms of transportation of the products when you can decentralize, but also decreasing on material and energy waste. So if you think about this also in terms of the product life cycle, you can imagine that as you're in the prototyping phase, you have relatively low volume, you're early in the stage. Prototyping, rapid prototyping is a very classic example of how to use any 3D printing technology. But multi-jet fusion can go certainly beyond that into bridge production, or even into full production. And I'll show you some examples of that in a moment, of how that's being utilized. We also see some great applications for, even if a product did not take advantage of 3D printing during the prototyping or even during the heavy manufacturing stage, the concept of using 3D printing for spare parts is one that I think will open up a lot of opportunities. We call those the long tail spare parts. There are also applications outside of your typical product development cycle that include things like fixtures and jigs and tooling that we see great advantages for. So back to that example I was saying before about how we're actually using this technology today in manufacturing. I'm going to cite two examples. One is our own in-house example, and the other is an example of one of our key customers. So the in-house example is, again, this is the 500 series, and what I'm showing here are all the different parts that we actually are printing. So it's printers making printers. It turns out we're using let's say the 4000, 5000 series to print all these parts that are going into the 500 series. As you see here, 140 unique parts that are being printed, they're actually going into this device. And we're not doing this just for the fun of it. We're doing it because it makes both economic and time to market sense. So we really were, as they say, eating our own dog food, and it really turned out to be truly beneficial to us. And here's a little bit quicker look at, or a higher level look at all the different parts that are in that system. The one that my eye always goes to, I'm a mechanical engineer by education. I did some engineering in my work before shifting to the dark side, if you will, into product marketing. But the one that catches my eye whenever I look at this slide is this one right here. You could maybe look at some of these others and say, oh yeah, that could be injection molded, that could be injection molded, maybe, right? But this one really is so unique, right? And I think why I point to this is that when you think about designing for additive manufacturing, in many ways you have to unlearn some things that you've learned in terms of how to design parts for injection molding. And that's part of the challenge, and that we want to pass along through higher education. Thinking about different ways to design a part for how it could be packed into a build chamber, for instance, or how it can take advantage of thin walls or intersecting walls that normally would create sinks in an injection molding. So there's all sorts of different considerations that you'd need to understand in order to truly take advantage of additive manufacturing. One other example I'll showcase here is SmileDirect. SmileDirect is a company that makes clear aligners to straighten your teeth. One of their big applications is, and by the way, it's all done, it can all be done remotely. You can they can send you a package that you bite down on this to take an impression. You send that to their lab. They do all the analysis and they come up with their plan for how to create the liners that will get your teeth as straight as you want them. The way that process works is that they have kind of the beginning state and the end state of your teeth. And what they do is they print, using our technology, dental arches for many different iterations along the way. So if it takes 20 different aligners to get you from where you're at today to where you need to be, they'll create 20 of these arches and then vacuum form a clear plastic around that 3D printed arch and then send you just the aligners. SmileDirect, this is what I was talking about before. The future is today. SmileDirect owns dozens of these printers. As you can see, they have 24/7 production, 50,000 plus unique parts per day, and they're printing millions of these aligners in the next 12 months. So if you had thought that before that 3D printing was still, just relegated to rapid prototyping, maybe some small production runs here and there, hopefully this will help you understand, not just from the example of HP on HP, but it is in a case of what SmileDirect is doing with our technology, that things have really changed and the world is moving into this industrial revolution 4.0. And I think the challenge here is that, are we ready to prepare the next generation workforce for this new reality? And that's, again, where higher education comes in. We need to be able to bridge the additive manufacturing skills gap, thinking about some various courses of study that could be impacted by this new future. You have your business administration. I talked before about supply chains and how to make all the decisions about where we source materials and manufacturing processes through. Obviously, mechanical engineering and industrial and product design, material science as well. So there's lots of different courses that will ultimately be impacted into these future careers that are in many ways dictated by this transition or this manufacturing revolution into 3D printing. So when you think about those challenges, we think that these universities like your institutions could benefit from multi-jet fusion in many ways. So for one, you can if you bring this jet fusion solution into your institution, you can now have a meaningful additive manufacturing education and exposure. You're going to be able to develop the next generation of these decision makers and innovators, and educate these engineers to take on some of those challenges of design that I referenced before with that part in our printer. You're going to be able to differentiate your school. You can build an additive manufacturing brand with a technology like multi-jet fusion. I think I've walked through many universities, and I see some that are kind of maybe dipping their toe or kind of taking some gradual steps into multi-jet fusion. A device like this could truly be a crown jewel in a university's model shop for showcasing what they're committed to and what technologies are out there in the world. I mentioned before about being able to run an efficient shop. We talk about the speed of this system. It's not just kind of that raw speed, but the ability to manage when you have a glut or a surge of jobs coming in. And I think universities are a perfect example of that. It might be quiet for a few weeks, and then suddenly when it's the end of quarter time, all these jobs come in. You could be overwhelmed if you didn't have a printer that could meet the speed. And so this system can truly do that. Hopefully you saw in that video that this is a very clean and easy to use system. We we took a lot of pages from our playbook from 2D printing, making those as easy to use as possible with the cartridge approach to our material containers. You saw that it was simply, sliding a cartridge into the system, and it takes care of the rest. There's no messy exposure to the powder in terms of pouring in into some sort of a hopper. It's a very clean and elegant experience with also very easy to use software. We've talked with many universities who are allowing their students with a little bit of training to run the machines themselves. As we talked about before, meeting the needs of the student projects, so these are truly functional parts that can go through any amount of, let's say, rigorous prototype testing or even final part application. So but there's also a lot of versatility that you can imagine here. Shouldn't just be considered for engineers. With the value of color and the fine detail and intricate features, you can think about this being used for anatomical models, dental arches, industrial design projects, art projects. So there's a lot of versatility you should be able to see from this system, which comes in many ways from the ability to print in color. I mentioned that this is truly unique in the market, that there's no other product that can make truly functional color parts. The other color technologies are binder jetting, which is super fragile. It's made out of just gypsum, and you dunk the part in super glue, but even still it's super fragile and can't really be put in any functional application. And the other is material jetting, which there too, it's a photopolymer, and you're not going to get any real Z strength or fine detail performance. The other thing that's, I think, interesting about printing in color is that you can expand and open people's minds about other ways you can utilize it. It's not just for creativity. It can also be for truly industrial applications like QR codes or CE labels on the part itself. With this solution, we also allow you to bundle to fit your requirements. The solution purchase will include access to HP's premium curriculum package. I'll describe that in more detail a bit later, but also the ability to buy multi-year care packs for maintenance and service so that you can front load your expenses. And then lastly, which I'll highlight again in a little bit, we offer some tremendous education discounts. So again, this is my vision for how I see universities and higher education taking advantage of this technology. But let's see what we have from one of our early customers, Clemson University, who took this technology on as having great success with it.
Clemson University is a public institution in South Carolina. As engineers, we have a lot of great ideas, and in order for us to be able to kind of realize those, we need an ability to see what we're dreaming. 3D printing is used within our senior design course to allow the student to see their product for the first time.
The Multi-Jet Fusion 3D printer is really incredible. Being able to print on the micron scale is mind-blowing. It's extremely helpful to have a printer that has that really low tolerance that can pick up all of the specific details we really need.
If I could only have one printer, it would be the HP Jet Fusion machine, just because it's easier to use and it's faster and it has super high quality parts. These stronger parts are actually allowing the students to do physical testing on their apparatus.
When our students see a prototype for the first time, their reaction is usually one of amazement.
It's fun to watch them when they first come in, and I give them their part and they go, wow.
The first one that we printed, it was pretty incredible actually, because we put it in and the next day we were able to pick it up.
We can just take all the projects we get at the end of the day and put them in the printer, and I come in the morning, and by 9 o'clock I have all the parts ready for the students to pick up. We started using color for everything now. I can print the black part, the red part, and rainbow colors and everything all in the machine at one time.
They've been able to realize their dream, what they're thinking in their head, what they see on their computer. So it's really a moment for them of true learning inflection.
It has effectively increased the capacity for the researcher in our lab by an exponential margin.
When they realize that they can do anything they want to, anything that they can design, basically we can print. I think that's going to change what they want me to print.
We're exposing them to how 3D printing processes work. They're able to use that in their education, but we're also teaching them how things are going to be made in the future.
Oops. Sorry about that. So, Kevin, I think you were going to talk a little bit more about some other examples of how customers are using the
Yeah,
technology.
perfect. Yeah, I just wanted to take just a minute and kind of talk about our view and where we see 3D printing and the evolution over the last, really 20 years. And kind of why HP is different as you educate kind of the future workforce. But I kind of, if you look at almost all manufacturing, they got this design wheel, right? And they come up with a concept, and the real goal is to get around that design cycle into production quicker, faster, and more innovative than anyone, right? And if I look at it 12 years ago, and Jeff talked about it, we sold a lot of traditional prototyping machines like Z-Corp and powder-based and jetted things. And we were teaching, universities and high schools were using them to teach students how to use 3D print. And then over the last couple of years, 6 or 7 years, right, we've seen these sub $5,000 FDM printers. And not only has education used them, but obviously so has manufacturing. So we kind of started to use them in that first 3 cycles of the design cycle. But what's really changed with HP and other companies like Carbon is now we see our customers using these products for production. And why is that different, right? Because I walk into a lot of schools and universities, and again, those entry level, either photopolymer machines or FDM machines have a purpose in showing concepts. But truly, I believe very strongly you're going to continue to see our manufacturers, especially in the Midwest, leverage true production utilizing additive manufacturing. Example, perfect one is HP doesn't build the machines, right? They farm it out. And those 150 parts that they are using, it's not because HP owns the machines, it's because it's more affordable for that assembler and that manufacturer to put it together. And so especially recently with COVID issues, right, supply chain disruption and that, we continue to see this evolution that 3D printing is no longer just for prototyping, but really for manufacturing. And the challenge that we see out there is the educated engineer that knows how to leverage the technology, right? It is a different way to look at things when you're building things in powder. You got to, it's really just as we did in the world of CNC and injection mold. You have to learn best practices. So I think we're going to see a very strong demand for that type of talent. And and the more you can teach and educate them, I think the stronger we will build our manufacturing in the Midwest. And if you go to the next slide, Jeff, this is just kind of an example of customers. Obviously, some of them like the Harleys and Milbanks and Spectrums. But what I want to point out is Re3D Tech and Fast Radius are both basically short-run manufacturers, all built around HP technology, right? They're suppliers to those bigger players. And we had not seen this until the last 2 or 3 years. And my last example I'll give for the education is Enerpac. Enerpac, are adding an HP unit to display some injection molding because of the advantages of time to market, overall cost. And what's interesting about that, it's a 28-year-old kid. You can tell I'm older, right? I'm in my 50s. But it's this 28-year-old kid that has had this passion and this knowledge around 3D print. And they're implementing this, again, pretty large scale project to make Enerpac more efficient, faster time to market, innovative. So this is where, again, this is a little bit different product than we've traditionally seen in the education world. But I believe more than ever, our students need to learn this. I know MSOE is on the webinar here. They've been at the forefront of that years. But I think this is why I'm excited about bringing HP to the educational market, because again, that skill set is changing, and we're going to continue to leverage new additive manufacturing technology.
Thanks, Kevin. So I'll just take it a little bit further from here and talk about this process of educating these future innovators. Can't just be done by bringing a printer into a model shop at the university, for instance. It'll take more than that, and definitely a curriculum would help move that along. And so what we've done is we've developed a additive manufacturing curriculum to help educate that future workforce. This will be intended for undergraduate or bachelor's degree studies. It'll be segmented into 8 modules, and the format will be a PowerPoint slide deck with speaker notes. Each one will be targeted for, each one of these modules will be targeted for around 90 minutes to 3 hours of content. So you can see that there's a wealth of information that we'll have here. You can see kind of some of the highlights of the modules that we'll be carrying. These modules in the curriculum will be released in 2 different waves. The first wave is just around the corner in July. We'll release these first 4 modules, and then the second wave completed at the end of our fiscal year in October, the remaining 4. So the idea is that we're going to offer this in 2 different forms. One is the foundational curriculum. This foundational curriculum will include all of these 8 modules that I just mentioned. It'll be free of charge with the completion of a survey, and it'll be accessible by all learning institutions. So again, our aim here is not just to sell printers. We certainly would like to do that, but we also need to educate the future innovators, because if people and engineers continue to design with old methods, we're not going to see this transformation that we talked about. It'll only come when engineers and future innovators are thinking about design for additive manufacturing and the benefits that that can bring. So that's why we want to make this foundational curriculum broadly available. For those who do purchase a system or currently do own a system, we'll offer a premium curriculum that will have everything that comes with the foundation curriculum, plus access to an exam and HP certification if you pass the exam, additional design for multi-jet fusion content that's valued at $2,000 currently with our professional services team that will be added in at no charge. And then some additional case studies and industry examples. As I said, this premium curriculum would only be bundled with a purchase of a printer, and it's only for degreed programs. But do please look for that and coming out in the very near future, the first wave, as I said, coming out in July. The last thing I'll point to is as the entire bundled solution. As I mentioned before, we have some education discounts. We have 2 different flavors of our 500 series product that we showcase here. The 580 is our full color printer. The 540 produces white only parts. You can get a 10% discount off of the list price of the hardware with the 540 for education purposes. And on the 580, you can get a full 20% discount on that system. In addition to the hardware discounts, we would offer a 10% discount on all consumables. This includes the material, the colorant and fusing agents, as well as any of the long-term consumables like lamps, filters, cleaning rolls, etc. So a full 10% discount on those. As I mentioned before, you get the premium package of the curriculum with any hardware purchase, a 1-year warranty, and again, the option of bundling a multi-year care pack for any of the cases where you need to front load your expenses. So again, this is the options that are available with the 500 series. The last thing I'll point to here is with an acknowledgement that not all universities, that these options may not fit all universities' budgets and constraints. We are offering a new alternative that's called 3D as a Service Plus. So this is a concept with a different product. So this is now the Jet Fusion 340 printer. So this printer is just like the 540 printer that produces white only parts. It has a little bit smaller build chamber. And we can get all these specs to you after the fact, but it is a slightly different product. With this version, what you can do is you get access to this printer in a pay-per-use model. Think of it almost like a rental, if you will, right? It's all inclusive. This pay-per-use model integrates the hardware, supplies, and service. So with a low $5,000 initiation fee and either a $2,000 fixed monthly fee, that would be for if you're on a 2-year contract, or even if you just have a 1-year contract. So only a 1-year commitment to the system. If you pay a $2,500 monthly fee. And then on top of that, you would be paying on a per build basis. So think of it not like you're purchasing material and agents and all the consumables. You're not. In fact, all you're doing is paying for the outcome. You're paying for the build. In this case, I'm showing that a full build would cost around $460. That would produce roughly 30 to 30 cc parts. That would vary. If you have a shorter build, you'd pay less. If you have fewer parts in the build, you'd pay less. So there's a formula that dictates what this price would be, but you're paying per build plus this fixed monthly price. If you think about the typical usage of a university, we see the annual expenditure, and again, this is inclusive of the initiation fee, the monthly fee, as well as all the build fees. The typical annual expenditure would be less than $50,000. So if that's kind of what your budget can handle, then this could be a really great option for you. And again, this includes the shipment of the device, any of the training, automatic replenishment of the HP supplies. This is a really cool thing. We remotely monitor the levels, so we ship supplies to you proactively, so you never run out and you never have to order consumables. There's also a very convenient online dashboard for easy tracking and cross-charging. I think one of the typical models in universities is that you're maybe having to cross-charge to different departments if they print. With this service, you would know exactly what that build costs and could cross-charge accordingly. So that was another, I think, an innovative way to get access to this great technology, and it could be a great tool for you in a university setting. So I think the last slide then is back to you, Kevin, to talk about any other follow-up resources and actions.
So this is just kind of follow up on some of the resources and action items that we hope are beneficial. So one of the things is there's 2 really good white papers, I would say great white papers that HP has put out around education. You can go to mastergraphics.com, go to the Expert Advice Center, and they're right near the top, and you can download them. And again, I think most of this came from my email, so you can send that back. The other thing is we have the ability to do remote Zoom demos. Obviously, we realize in today's world, you can see Mark there with our application engineer with some lights on him. But we can actually do a virtual demo so you can get a feel for it without actually having to come into our location in Wauwatosa, Wisconsin. And again, that's also available in the future as well. And then, of course, ongoing support. This is really critical. One of the things we found in education is, and Jeff said it right. I mean, the HP is really doing a lot of things. We are much like them. Just from a holistic approach, we think it's important to support education. But we realize a lot of times you have new students coming in. So as part of our support, we'll come in on, each semester as needed. We've even, often come in and our application engineers or myself will speak to the students about what we're seeing in the industry. Again, we feel that's really important, not only to make sure that every semester or term that you're using the equipment properly and the students are being trained, but that we really are sharing our knowledge that we're getting so that not only you, but your students know what to expect. The last other thing that we've been involved with is fundraising. Again, I'm very proud of the Midwest, but we've worked with a lot of tech schools and universities where they've gone out and worked with businesses to get funding, right? And then the businesses might use part of the machine. They might, they helps train people for them. So if that's the case, you can, again, come to us. And then the last thing for your joining us on the webinar, if you email me your school name, or even if you want your personal name, we'll print 5 bottle openers on this technology and send it to you. Now, I thought about a bottle opener. I don't know that's the right one if you're a high school, but again, that is something we'll do. But I can't stress enough on the education side, even if HP is not the right fit for you, you can, please reach out. We're always willing to talk, meet with students, again, come out and give you some training just to make sure that, again, the Midwest is the strongest in education. So with that, I think the next slide was just question and answers. I had some questions come in. One of the good ones was, and I'll let you handle it, Jeff, is how do you clean the part after printing?
Yeah, good question. In the video, you saw that the parts, there's an automatic extraction where it removes any of the unused powder. what you're left with is a part that has a little bit of powder still stuck on it. And our recommended cleaning process is a simple bead blaster. We use glass beads, but any type of bead blasting could be enrolled in doing that. So yeah, it's bead blasting is the cleaning process.
And then again, another one, when I say we do remote demos or demos, we walk you through the whole workflow, but that part is fairly, compared to most, fairly easy. The other one earlier was asked is some of the video came across choppy. So as a follow-up, I will send out a link to this and if you want to view it again, but I'll also post the videos with a link so that you can see them with the entirety. With that, I actually see proactively one of our attendees answered one of the questions on the materials. But I think that's probably all the questions we have at this point. Anything else from your side, Jeff?
No, I think that's it for today.
Yeah.
Thanks
well,
again
like
for the time.
Yeah. Sorry. We appreciate you attending. Thanks, Jeff. Anything else? Sorry, I cut you off.
Nope, that was it.
So we appreciate it. Like I said, we'll repost it, follow up again, email me if you want your free bottle openers. And like I said, truly on the education side, if you ever have a request or you really just want to talk 3D printing, I'm passionate about it. We're passionate about educating our students, and we'll do just about anything within reason to help you educate our future. So again, with that, go off and have a great, beautiful day and enjoy.